project,
Yes, sir.
and whatever you need in terms of material, in terms of data set, in terms of Python program,
Yes.
is what I and Sharad sir of your institute will be providing you, and Sharad sir is there with you personally to go ahead and explain you the Python programs and everything, and that's how we can make a huge success to this AML program, which
Okay,
we
sir.
are doing, and which we are spending time to learn the particular concepts of AIML in a
Yes,
big
sir.
way. That's what I want to say. Thank you very much. And now we can start this session at 10
Good.
o'clock.
Sir, can I have a few words, sir?
Yes, sir.
Yes, sir. Sir, we are very sorry to for the delay in response from the students, also from our mentor side, sir. But what was happened was, sir, it took some time for the students as it is a new subject to respond, and
Uh,
also we the mentors also we have attended some basic trainings earlier in the lockdown, but we took some time for us to to reach the level of understanding from the presentation
no problem, sir. No
for us,
problem.
and also there is a delay in creating the assignment questions from our side, so that the students uh, didn't get enough time to to work on that. So that
No
is why
problem.
what I have done is, by Thursday we got some questions, sir. Actually, Thursday is the deadline. At that time, we got some questions. So I thought that we need to give at least couple of days for the students, so that they will be completing by this Sunday or Monday. So
Hmm.
that from Monday, again Monday, we will get new assignment questions from the mentors, from your point, from your course from the Saturday. So that's what we thought, sir. But there is a communication gap. I didn't, inform pass this message to you. So that is why this small inconvenience was happened, sir. And I really thank you for coordinating, sir. And in WhatsApp group, we are following up, sir. And the inputs that you are giving in the WhatsApp group also has been followed by our mentors, sir. They are working on those solutions, but only thing is, we are sometimes we are not responding in the group. That is what is happening. We will definitely respond to you in the WhatsApp group from now onwards, sir.
Yeah,
Okay,
no
okay,
problem.
sir.
No problem.
Okay, sir. So that's the only thing, sir. But nothing else, sir. Our mentors or myself also, we are working on those, because it's kind of new thing. That is why it's taking some time to understand those concepts, sir. But even though it is delay, but we are not going to leave this incomplete. We want to complete the
Yeah.
entire thing, and we
No,
will we
it
will
is for
we will
your
submit.
benefit. It
Yeah,
is
we
for
will
the
submit
benefit
the
of
assignments.
the
Yes, sir.
students and the faculty
Yes, sir.
that we are conducting this course, and your HOD sir,
Yes, sir.
he has told to conduct this particular course because AML is going to be a hot cake in the
Yeah.
coming years.
Yes,
And
sir.
what we want to say is, you
Yes,
have
sir.
any questions, you can ask, and
Yes, sir.
I'll
Yes, sir.
try my best to go ahead and satisfy you
Yes, sir.
your questions that you have,
Yes, sir.
and that's how we will move forward. No problem,
Definitely.
sir. No problem.
Definitely.
Thank you
Definitely.
very much. We
Sir,
have another
thank you
5
for.
minutes left, and we'll start the session. And
Okay.
today,
Yes, sir.
I'll take the session on the next type of learning, which is
Yes.
known as unsupervised learning or
Okay.
clustering.
Okay, sir.
And then I'll share all the PPTs
Yes,
which
sir.
are there,
Yes, sir.
and share all the material for
Yes, sir.
the assignment which is there
Yes, sir.
with the teachers first.
Yes, sir.
Uh,
Yes,
and
sir.
then you give only the teachers are the interface of the student and
Yes, sir.
the particular material that's there, and then we'll go ahead and uh, educate the students. So the
Sure.
ultimate responsibility lies with the teacher to go ahead and educate the student
Yes, sir.
in the right fashion. Hmm.
Sure. Sure, sir.
so that
Yes, sir.
everything is passed to
Yes, sir.
the student, whether it be assignment, whether it be solutions, whether it be material,
Yes, sir.
and the student basically learns it because the student is the one who is going
Yes,
to
sir.
face the interview in the coming 6 months,
Yes, sir.
and then they will ask him, and he should be able to,
Yes, sir.
he or she should be able to answer well.
Yes, sir. I agree, sir. Yes, sir.
Okay. Now we'll start this particular session in another 2 3 minutes.
Just give us 5 minutes, sir. Give us 5 minutes.
Okay. Okay,
Uh,
sir.
Sir, we are arranging the all the students in a classroom and arranging the projector and also the video and audio for your lecture, sir. So give us
Yes, sir.
5 minutes, sir. There is a delay of 5 to 10 minutes. Don't worry, sir. So it is going to
Okay.
be good, sir.
I hope you are able to see my screen.
Yes, sir. Yes, sir. We are able to see your clustering screen, sir.
Okay, sir.
Okay, okay, sir. Okay, sir. Thank you.
And
Thank you, sir. Thank you for.
I have shared all the technical stuff with Sarat sir first.
Okay, sir. Okay, sir. And
And
sir is also posting in the Google Classroom, sir. No problems. I can
yes,
see.
sir. Yes, sir.
Yeah, I can see the
So,
classwork, one A, C, and also feedback, etc. So definitely, sir, we will follow it up, sir. Please give us time for 5 minutes so that we will uh, alert the students for the class, sir.
okay, sir.
Okay,
Wonderful.
sir. Okay, sir. Thank
Thank
you,
you
sir.
very much.
Thank you, sir.
Hello, Sudhakar sir. Hello, Sudhakar sir. Hello, Sudhakar sir. Hello, Sudhakar sir. Hello, Sudhakar sir. Hello, Sudhakar sir.
Sir, sir, this is Sharat sir.
Yes, sir.
Sir is arranging the gathering the students, keep in one particular room and arranging the camera and set up the classroom.
Projector.
Okay, it take around 5 minutes, sir. That I would ping you. Everything is ready.
Okay, sir.
Okay, okay, nice.
But you are able to see my screen, right?
Yeah, you able to see the screen that is clustering slide.
Yes, sir.
Yeah,
Yes.
yeah, yes, sir. So it's around 5 minutes time. Okay,
Okay, sir.
okay, right.
Okay.
Nice. Thank you.
What we'll be doing is today we'll be touching upon the topic of clustering, and those will who have done the assignment
Okay.
of classification,
Hmm. Okay.
they can go ahead and present their assignment which they
Okay.
have done. Mhm.
Okay.
And the other students can ask them the questions.
Okay.
uh, and the student and the guide, they are responsible for presenting their assignment on classification,
Okay. Okay, sir.
and then we can give the right answer to everybody. The teachers can give, the
Okay, sir.
respective teachers hmm,
Okay, sir.
can give the right answer of classification assignment
Okay.
to all the students, and 1 hour for the presentation,
Okay.
and 45 minutes for the uh, student presentation.
Okay, sir.
And there are five mentors, right? Five teachers, right?
Yeah, yes, sir.
Okay, sir. So five teachers means each one can take around 10 minutes
Okay.
and have their students present the previous assignment on classification.
Okay, sir.
And then we'll give a new assignment to the students and to the faculty, and the faculty can guide them.
Okay, sir. Okay.
Okay, sir.
Okay, sir.
Uh, are we ready to start? Please let me know.
Uh,
Yes, sir.
Okay, sir. Uh, Good morning, everybody. We are starting the second topic, which is known as clustering. In the first topic, that is the classification, that is supervised learning. We have seen that we have to supervise the type of learning to the machine, computer. We have to supervise. Blood in clustering, there is no supervision. And I'll talk about this topic in little bit detail, and also there is an assignment on this particular topic. So I request you all to follow this topic and go ahead and ask me any questions. Briefly, the lecture outline is we'll be talking about clustering. We'll be also discussing about the supervised and unsupervised, and we'll be talking about the different clustering algorithms, and the result is at the end is what we are talking about. I just want you to know that clustering is a sort of unsupervised classification. In this unsupervised learning which is happens, what we are going to do is we are going to cluster all the objects. For example, if they are round objects, then let us take for example apple. Let us take, for example, orange, and let us take coconut. What we are going to do in clustering is that since all the three are round objects, we are basically going to go ahead and put them in a particular basket, and we are going to say that all these three, since they are round, we have gone ahead and put them in one basket, and we can say that the observation of the feature, which is roundness, is there in all the three. That is why we have clubbed them together. But it is not possible to go ahead and say, for example, that whether each is a different type of object. Here, what we are saying is simply we are saying that because it is round, we have grouped them together and we have done unsupervised type of learning. Now, we'll go to the definition of clustering. What do we do in clustering? We are grouping the similar items, we are grouping them together. Since all the objects are round, we are grouping them together. Then clusters should be very similar to each other. When we are saying that the cluster of round fruits which are there, whether it be apple, whether it be orange, or whether it be coconut, we are saying that we are grouping them together. That means we are putting them together in one particular area, and that could be a basket where we are putting the round objects together. We can say that the intra-cluster similarity between the objects is high and the inter-cluster similarity is low. What does this really mean? This really means that the objects which are there in one of the cluster, they are having the similarity between the objects is very high because they all around, and the intercluster, when we are saying from cluster 1, cluster 2, what we want to say is cluster 2 which is there, the similarity between cluster 1 and cluster 2 is low, because in the cluster 2 what I have placed is I have placed the fruits which are having some shape. For example, the shape may be conical in shape. For example, there is a guava. The shape of that guava is not round, it is having a cone like structure. And that is when we say that the objects which are there in one of the cluster between uh, one of the basket is having a similarity which is very high because they're all around, and the similarity between the second object is going to be low. Imagine if in basket 1 I kept all the round fruits which are together, and in basket 2 I kept fruits which are having a conical structure, and that's why we are saying that the similarity is very low. And uh, what we want to say is that you like the last point, important human activity from early childhood distinguish between items such as cars and cats, animals and plants, etc. For example, there is on the road a particular type of car which is there. So all the cards, we can say that the cards may be of different types, but we are basically clustering all the cards as cards and all the cats as cats, whether it be a cat from India or a cat from Japan or a cat from America. We are clustering them all as cats, and whether that be animals or whether they be plants. And we can say that when we are forming the cluster, we are actually not going into the details of the particular object which is there. But what we are trying to do is that if it is a shape of a car, then we are clustering it as a car, and if it is the shape of another cat, then we are saying that it is a cat cluster. So like that, what we have done is we have formed a cluster, and as you can see out here, this is also known as unsupervised type of clustering. Here there is no supervision, and just if it is round, then put it in the object. If the shape of put it in one of the cluster. If it is the shape of the car, then put it in the cluster of the car. If it is the shape of the cat, then put it in the cluster of the cat. So you can see that there is no supervision, and that's why it is known as unsupervised. So this is the second type of learning that you are basically going to know about in this particular lecture. In the first lecture, what we discussed is basically classification, in which we used to, on the variables of x, x1, x2, xn, we used to give the result of y, that is whether the person will play or not in this particular area. But in the case of unsupervised, in the case of clustering, we do not go ahead and try to say that this particular fruit is a apple or an orange. Rather, we say because it is round, we are going to form a cluster of the fruits, of the cards, of the cats, and this is a type of learning which is also there. Now, what is the difference? You have to be very clear. First is the supervised, and second is the unsupervised. In this case of supervised, we call it classification. In the last lecture, we have seen that when we call it the supervised step of learning or classification, what we have done is we have actually said that if it is x1, x2, x3, x4, and xn are the variables which are there, then we can easily say y is y, which is a function of x1, x2, xn. It is a function. But in the case of supervision, which is unsupervised, we do not say that it is a function. Rather, we say that because it has a particular feature, we are basically going to have this particular things grouped together, and this grouping is known as the unsupervised learning, and this is known as clustering. Now, how do we achieve clustering? We achieve clustering by going through the various clustering algorithms which are there. Now, I just want to let you know that there are several methods and techniques which have been developed, and this help in grouping the different objects. And when you're doing a research or something, if you do in the area of clustering, that is unsupervised learning, we can easily say that it's a popular area of research. And these are some of the books that have been written in the area of clustering. Now, let us take the different type of clustering algorithms which are there. Hierarchical methods. Hierarchical methods are basically of two types: agglomerative and divisive. Agglomerative, we will discuss about it, and divisive means we divide. And in case of partitioning methods, they are also a type of clustering. And we have the grid based method, and we have another clustering algorithms which are used in the case of machine learning, and we have different algorithms for the high dimensional data. Now, in the case of partitioning, we do partition of the problem based on the relocation based on the probabilistic based on the K methods, and K means, wherein we take the mean and then we do the density based algorithm. Like we can easily say, in this area, the density of the people is going to be high. Since the density of people is going to be high, we are saying that the density of the houses is going to be high, the density of cars is going to be high. So you are saying that I am really not drilling into the details, but when I'm doing clustering, I'm just saying that I'm going to have some of the intuitions that I have, and then I'm going to predict that this area is a high density area for the houses, for the cars, for the people, etc. And these are some of the ways in which we are going to go ahead and try to do the clustering. Now, let us learn what is the difference between the classification and clustering. Now, classification that we have learned in the previous lecture, we are going to have a supervised step for learning, and we learn the method for predicting the instance class from the pre-labeled instances. That is, in case of classification, we are going to have a certain condition under which we are going to learn that we are going to do that particular thing, or the why which is there, we are going to go ahead and execute that output, and this is known as classification. And this classification has a typical equation like y is equal to f of x1 x2 till xn, and that is known as classification. In the case of clustering, we are not going to have any such mechanism in which we teach the machine or teach the computer. Rather, it is type of a unsupervised learning and finds the natural grouping of instances given unlabeled data. Here the data, you have to understand one thing, that in case of clustering, the data is not labeled. We are not going to say that we are going to play if the conditions of weather, if the conditions of like sunshine are so and so. Rather, what we are trying to say is that in case of unsupervised learning, we are going to say we are going to go ahead and try to group these particular employees or these particular people or these particular fruits, and there is no such label that is assigned to the data. And what we want to also say is that for the evaluation of the clustering, we need to do some of the techniques, and some of the techniques are manual inspection and benchmarking. We is what we have to do on the existing levels, and we have to also see the cluster quality. Like, for instance, if the fruit is round, like we can say that it is going to be an apple or an orange or a coconut. And how do we determine that? We determine that by taking the distance between the different objects which are there. Now, if the similarity is going to be high, then we can say that this cluster is of the round fruit. But if the similarity is low, that means we can say that this fruit is conical in structure, and that's why we are saying that this is a different fruit than the round object. Now, what happens is the distance formula. We calculate the distance using a of x minus a of y. And when we calculate the distance, we can easily say that whether the fruit belongs to one cluster, or whether the person belongs to one cluster, or whether whichever we are trying to cluster, we are saying that whether they belong to one of the category or to a different category. And there are several distances that we take. The distances that we take are Euclidean distance. Generally, you would have learned that square root of x2 minus x1 whole square, that is known as the Euclidean distance, and that is the distance we take into account when we are trying to create some of the clusters. These are some of the ways, and there are several other distances also, like Manhattan distance, and one of the Indian scientists also Mahanabulis. Then we can say that when we calculate the distance between the data points, we can say whether the objects belong to one of the clusters or to a different cluster. Now, what we want to do is we want to go ahead and try to introduce one of the algorithms which is there, which is known as the k-means. It works on numeric data only, and what we do is k. We pick up just randomly one of the cluster centers at random. We go ahead and pick it up, and then we assign to every item its nearest cluster center. That means if it is a round object, we assign it to something which is round. If it is a conical object, then we assign it to a cluster which is some of the not round. Now, we move each of the clusters to the mean of the assigned mean, assigned items. Then what we do, we go ahead and try to assign that this particular object is basically going to move to the mean of the assigned items. Then we repeat these particular steps, and then we try to ensure that when the distance is very less, at that time we can say that this object belongs to this cluster. So I want you to note that KMC, K means clustering, is one of the famous algorithms which is there for the clustering, and it is very important that you be able to go ahead and explain to the person in front of you when you're talking about clustering. Now, let us see the diagram in which what we have done is we have done clustering. We have picked up the initial cluster centers randomly. Like you can see K1, K2, K3, K4 is something which we have picked up randomly, and the value of K is something we have just said that K1, K2 and K3 are these particular uh, points in which the clusters need to be created. Now let us see the second angle. The second angle is basically we are going to assign each of the point to the closest cluster. And how are we going to assign? We are once again going to find the Euclidean distance between the different points. And since we are finding the distance of the different points, which are basically to the uh, means, or that is K1, K2 and K3, we can easily say that whether one of the point is near to K1 or near to K2 or near to K3 is something we are going to find. And here you can see that he is trying to go ahead and trying to calculate the distance, and he is then what he's doing, he is moving each of the cluster center to the mean, or to the mean of each cluster. That is, he is saying that all of the data points which are there are basically going to fall into one of the categories, and this is how we do the clustering. And you can see, for example, what we have done in the fourth case. In the fourth step, what we have done is which points are reassigned. We just calculate that, we go ahead and calculate the distance, and then we see that the points which are there are basically assigned to one of the K1, K2 or K3. And in step 4, you are seeing that he, for that K1, K2 or K3, he is trying to calculate the distances. And when he is trying to calculate the distance, for example, whichever is nearer, he is going to assign that this fall within this cluster. And then we are going to recompute. So what we are going to do, we are going to go ahead and do the computation of the distance again and again. And when we are doing the distance calculation again and again, what we are really doing is we are saying that which of the data points are nearest to the particular k which we have taken, and for that this is forming one cluster, and we can easily say that, and that's how we will do the k-means clustering. And for doing the k-means clustering, we can find out some of the clusters which are there, and we can say the fruits are round, or the fruits are conical, or the fruits are not having any distance, or the cards which are basically occupying a lot of volume. They are under one of the cluster. Like, for example, when we are going to a car dealer, he is going to say, do you need a small car or do you need a large car? A small car is basically going to have less volume, a large car is going to have a bigger volume. What he's really trying to do, he's really trying to go ahead and tell you that I'm going to show you a cluster of the cars which are having low in volume. That means small cars, and cars which are to be used by bigger families. And that is how he basically shows you as per your budget. And then he is clustering the cars, as you can see, into small car, into bigger car, and then he showing you. Now, assume that I have basically done the clustering. Now, what is the point at which I'm going to say that my clustering is fully okay? I'm going to say that when I have clustered using the k-means algorithm, I'm going to say that the Euclidean distance measure is equivalent to minimization of the squared error. This many people are going to ask you when you need to stop, when the sigma, when the addition of p minus mi whole square and another sigma is equal to e, where e is the sum of the squared errors for all the objects in the database, and p is a point in space. And then what we have to do is basically the center of the cluster is denoted as C. So when I am basically going to have the squared error criteria at this particular point of time, I'm going to stop forming the clusters. And I can say that the clusters that I have formed are basically optimum. And this is what is the condition for stopping of the particular thing. Now, we have done k-means. Now, what are the pros and cons? The pros of k-means are that it is going to work well on the data when the data is compacted. Like I just want to say, when one of the fruit is basically, for example, it is round, it is not round, or it is conical. I can coolly say that if it is round, either it's apple or the orange or the coconut. But if it is not round, conical in shape, then I'm going to have it like guava or some other fruit. So if I applied K-means algorithm, then I can easily say, then uh, I can easily say that since it is conical, so it is not one of apple or orange, which is round in shape. And I just want to let you know that K-means is basically going to work well since the data which is there with us is basically separated from the different, like for example round and round, like for example conical data which is there for the fruit. So in this case the K-means is going to work well. And I just want to also say that K-means algorithm is scalable. Scalable means for all the fruits which are there, which are round in shape, we can easily say, take for example, apple or the orange or the coconut. It is round in shape, and that is how we can say that K-means algorithm is going to work well. And I just want to say the K-means clustering can only be applied where the mean of the cluster is defined. For example, wherein I am going to say that the roundness should be 50%. The roundness should be 60%. If I am able to define that particular thing, for example, I am able to define what type of roundness of the fruit is what I may take, then it's very easy to apply K-means clustering because all the fruits which are having more than 50 or 60% of the roundness, I can put it in one of the categories, or all the cars, for example, which are having less volume. Like I can easily say that if the volume is less, then if the volume is only this much for the particular car, or if the diameter of the fruit is less, and then I can form into one of the cluster. And this particular algorithm, it is sensitive to noise and outlier points. I just want to tell you that the outlier points are something which are beyond it. For example, if some fruit is having a particular height, like for example, let's take the example of a banana. For example, banana is having a particular height, a particular length, and that's why we cannot put this banana into the area of round fruit. And that's where we are saying that this particular K-means algorithm is going to work well. And also if there is a noise, for example, if there is some other data which is there, which is coming in the like not so round shape, we can easily say that it doesn't fall into the category of round fruits. And that's why when we are applying this K-means algorithm, you are saying that it is sensitive to the noise which is there. And then also to the outlier points, the points which are beyond this particular roundness. For example, let's take banana, we cannot put it into the category of round fruits which are there. Round fruits are only apple, only orange, or only coconut, and it is not possible to put banana or some other fruits which are not round. So when we are applying this K-means clustering, we are easily going to find out whether the fruit is round or whether the fruit is not round. Now, when the particular people found out that they are going to apply the means mechanism, they also found out that if you are going to apply the methods, then we are going to get a better result. For example, let us say there are numbers. For example, the numbers are 13579. And what is the mean of that? The mean of this particular number is basically 5. You can see that uh, when we are taking the median of this particular number, we are also seeing that when we take the mean or when we take the median, the number is basically 5. Then in that case, the advantage is they are not affected by the extreme values. You can see whether you take the mean or the median, and then they are not affected by the values which are there. For example, in this case, you are seeing that whether it's 1009 or uh, you are taking in this case the median is always 5, and then for large databases, hence we do sampling. That is, we pick up a sample and then we determine what are the algorithms that we should apply and how we should cluster them. Now, let us take for example, we are going to apply the methods. Now, this method is basically less sensitive to outliers which are there rather than k-means. When we are applying this particular method of the methods, at the time we can say that it is not so sensitive to the outliers which are there existing, and the cluster which is there, which is represented by the most central point in the cluster, that is the middle. And we will go ahead and minimize the number of the sum of dissimilarities between each object and its cluster reference point. Still we will go ahead and do that, and that's one we can say that the methods algorithm is now very convenient. Now, what exactly does the k-methods algorithm do? We have seen in case of k-means by the various diagrams which are there. Now we are going to see the k-methods algorithm which is there. And what here we do is we randomly choose the number of data points which are known as methods, and then what we do in the step number second is we repeat one by one, and then we go ahead and assign the remaining non-meta objects to the cluster which is represented by the most similar or the nearest method, and then we go ahead and, as you can see, this particular algorithm which is there, then we go ahead and randomly choose one of the non-rendered point which is there as the particular data point, and we also consider the current methods which are there, and then we can compute the cost of swapping. Here we just consider the cost which is incurred in the algorithm, and when the cost incurred is very high, generally we do not go ahead and swap them, and when the cost is incurred very less, we go ahead and swap them. And then when do we stop? We stop when there is no change, and this is what we do in case of the K-methods algorithm. Now, I just want to tell you there are some of these swapping methods what we have to do is basically we have to go ahead and uh, swap it based on the particular algorithm which is there in the k-method space. What we are going to do is we are going to have a particular calculation of the swapping cost which is incurred, and based on the swapping cost we either swap the particular points or we do not swap the particular points. And as you can see, he is once again calculating the cost. And after calculating the cost, whichever cost is the least, then he is going to swap that. Or whichever cost, he if there is no change, then he is going to stop the k-method algorithm per se. Now, there are four cases when we are doing the k-methods application. The case number one, wherein the P, the point belongs to the method which is OJ, wherein this particular if OJ is replaced by a method, then it is closest to some other method. In this case, what we are trying to do is we are trying to do the method of a particular point. And when we are doing the method of a particular point, we are saying that whether this particular point is close to one of the methods or whether it's close to another of the methods. Case 2, wherein we are saying that the point belongs to a particular method, and if this particular method is replaced by a method that is closest to the random point, then P is reassigned to this particular random point. So case 3 also we have to see, and case 4 also we have to see. And when we are saying that this particular point which is the data point which is there, which is closest to the method, and whether we are doing the swapping or not of the method, and then we are going to stop when there is no change in the cost which is incurred. Now, one thing we have to remember, when we are doing the swapping, the sum of all the costs should be a total of very, very less. If the total is negative, the swap is worthwhile doing. That means what we are trying to say is we want to keep the cost very, very low. And when we are doing this particular swapping, at the time we have to remember that the cost should be very, very less. So that is basically the K method application. Now, I just want to tell you the summary of K-means and K-methods that you have learned. Now, the K-means summary, that when you are using K-means algorithm to go ahead and cluster the objects, it is simple. K-means clustering KMC is basically simple, and you can say that the items are automatically assigned to a particular cluster, but the disadvantage of the KMC, that is the K-means clustering, must pick up must pick number of clusters before. That is, we have to determine the value of k, and that determination of the value of k is very, very crucial in case of k-means algorithm. But in the case of other algorithms, we do not need to determine the uh, value of k. On all the items are basically going to one of the clusters, that is K1, K2 or K3, and the K-means algorithm which is there, it is very, very sensitive to the outliers which are existing out here. And this particular existence of particular algorithm is basically we have to put all the objects which are there we have to put them in one of the clusters, that's K1, K2 or K3, which are there depending on the value of K. And when we are trying to do that, we are basically using the K-means clustering. And this is one of the disadvantages which is there of the KMC. Now, I'll briefly touch upon the agglomerative, what type hierarchical clustering and the divisive type of clustering which is there. In the agglomerative type, what we do is we start with a single instance of the cluster, and each step you can see out here that when we are going up, what we are trying to do is we are trying to join these particular clusters which are existing close together, and then we are trying to agglomerate it into a single cluster. Whereas in the case of divisive cluster, what we are trying to do, we are starting with one of the universal cluster, and we are finding two, then we are finding four, then we are finding six. So we are dividing, and both the algorithm, whether you say agglomerative or divisive, they will form a something which is known as the dendrogram. And you will hear about it more and more about the dendrogram, because what we are trying to do is we are trying to either do agglomerative, that is the bottoms up, or we are trying to do the top bottom, which is the division type of algorithm which we are going to follow. And once we follow this, we are going to do a type of a clustering of the algorithm. Let us take, for example, we are doing some of the supervision. It is an unsupervised type of algorithm, and in this case, a case you can see what we have done is basically we have basically gone ahead and tried to do the clustering, but we did not give it the type of supervision that is required, and this is known as the unsupervised type of clustering which is there. As you can see out here, what we have done is we have taken the different shapes, and these different shapes which are there, we have basically tried to share that this particular shape falls into one of the categories or one of the clusters, and hence we can say that this shape belongs to this cluster. So as you can see out here, that what we are trying to do is we are not trying to give any type of supervision to the clustering which is there. So here what is happening is this is a sort of a diagram or a Venn diagram, and when we are doing this particular type of clustering, what we are trying to do is we are just trying to take the points, and we are trying to put the points in a particular bracket. Now we want to talk about different type of research problems that are there, and you could say that what is the effective clustering that we should do. Say for example, there are some different types of people. Some people are having some different skin color, or some fruits which are there which are different type of roundness. At the time it is very easy to go ahead and try to form clusters of the different fruits of the different people, and these are some of the research problems which are basically there, which are for example, when you're talking about the complex shapes, when you're talking about the subspace, when you're talking about cluster overlapping, then these are some of the problems which are there. What are the examples which are there of the clustering algorithm? For example, we would take for example the marketing area. In the marketing area, what we discover it is we discover group of customers and use them for the targeted market. Now, is there any logic for the group customers that we choose? No, there is no logic. Just we have said because of their past experience of the person who is found in cluster, we can easily say that let us go ahead and try to put all the customers into one of the areas, into one of the clusters, and then let us do this particular expertise on them. And then when we do this particular uh, expertise on these particular group customers, then we can say that okay, whatever is the result, we can say this is basically the cluster of customers which is exhibiting a particular behavior. Whether you do astronomy or whether you do the earthquake prediction, it is very easy to go ahead and try to form clusters. And these clusters maybe go maybe right, maybe wrong. Sometimes when they are wrong, we have to define our method. And I just want to let you know, in case of machine learning, there is continuous refinement, and then when this particular thing occurs at that particular time, we have to continuously go ahead and refine our algorithms. We have to continuously go ahead and refine the way in which we form the clusters, and this is what happens in case of the clustering application. Now, I just wanted to take you through one of the slides. Before that, any questions? Please unmute and ask your questions right away. Any question, please? Any questions, Sudhakar sir? Okay. If there are no questions, then we'll go on to the next one. That is the various applications of clustering which are there. And when we are saying the different applications which are there, for example, let us take the market segment problem. And when we are taking the market segment problem, we are trying to see whether a market segment can be formed of the different customers who are there. For example, here I have taken this particular ratings which are given by the customer values of a particular carpet fiber. For example, the members who are there are basically schools or light or commercial, light commercial, or whether they want indoor carpeting or whether they want help carpeting. So I have formed some of the cluster which are there. Now we are going to automatically describe the particular structure which is there, that is existing in the data. And the challenge out here is that there is no training data. That's why it's known as unsupervised type of learning. For example, when we are taking a some of the people of one of the family, we are saying that it's a very, very vague problem. And that is what we have to go ahead and have some clustering done for the different type of people who are there. Some may be tall, some may be having some different size shapes, some may be short, and so on and so forth. We can say we are doing a cluster. Now, what happens when we are doing a image cluster? Let us take, for example, when we are taking a particular image which is there, and we are doing a particular cluster for that. We can easily just, if we are using k-means algorithm, we are just taking randomly a value of k, and when we are taking a value of k at the time, we can easily say that depending on the value of k, I'm going to form some of the colors which are there, and some of the colors which are there. So that is how I'm going to go ahead and do image segmentation for that particular value of k. Now, the other applications which are there of clustering are basically a particular document. If you are there, then these particular documents which are there, they organize these particular documents into a set of content similarity. That means some of the documents which are there are basically going to give you the news which you get, and some of the documents are basically going to give you some other topics. For example, some of them are going to give you sports. Some other applications which are there, you have to segment the customer based on their similarities, and then you're going to form this particular cluster. For example, this I have already told you that when you're doing unsupervised learning, you're basically forming clusters, and when you're forming these particular clusters, at the time you don't need any supervision. For example, just you're saying that you are having some of the data points, and when you're forming these data points, you're forming the cluster as per your requirement, and you are basically going to go ahead and have this particular algorithms which are there in the case of unsupervised learning. That means there is no supervision and the clustering is formed. What you're doing in case of clustering, you're finding basically the similarity groups, and then you're saying that this particular data point is basically going into one of the clusters. Now, I also discussed this earlier, but I'm going to discuss it once again, that you can have either hierarchical approach wherein you create a hierarchical decomposition of the data objects by using some criteria. That means you can say that when you are trying to do clustering, this particular set of people, they belong to this particular era. The older people, for example, they belong to a particular era. Then you are doing nothing but a hierarchical type of clustering. And when you are doing a partitioning type of clustering, we form the different partitions. And this different partitions, when we are formed, we are saying that we are basically following the partitioning approach. And then we are doing a model based, like on different model, we are basically going to go ahead and partition and form the clusters. So we are saying that we are going to do a model-based approach. For example, a Gaussian model. What does the Gaussian model accept? A Gaussian model says that the data is evenly divided on both the left and the right side, and that's where we try to use this particular model, and we try to do the clustering based on this particular model. Now, what is hierarchical modeling? Hierarchical modeling, as you learned in the previous slides also, is when we form a hierarchy of the things which are there. And when you are trying to form a hierarchy, at that time there is not required that you have the previous data which is there. So here what you do is basically you just see what is better, basically uh, your connection between the different objects which are there, and you can say that the distance between the intercluster, that means two different type of cluster will have the least similarity, and two different type of cluster will have the greatest similarity if they are belonging to the same cluster. Here, for example, I'll basically take for you an example in which I'll basically have the distance which is there between the two data points. As you can see, the distance between the San Francisco and the Los Angeles is very, very high. For example, when you are saying the distance between the two is very, very high, you cannot put them in a simple cluster. Whereas the distance, when it's low, you can put them in one of the clusters, and you can see that what I have really done is really based on the distance which is there between the different airports which are there. BOS stand for Boston, New York, and then you can say MIA stand for Minneapolis, CHI stand for Chicago, and then you can see what he has done is out of this particular data, he has basically gone ahead and said that which of the distances are basically less and which of the distances are basically more. And the distances wherein the distances are basically equal or having less distance, he has basically clustered them into one of the areas, which is you can go either to Boston or to New York or to DC or to Chicago or to Denmark. What is done is basically those airports are basically in one region, and the distances which are basically far off, he has basically said that you will basically have this particular airport in a different region, and that's how he has basically taken the data points and he has calculated the distances. And when he has calculated the distances, what he has said is those where the distances are very, very less, he has found one of the cluster, and where the distance is very high, that means you are basically saying that this is a different cluster. And we just want to let you know that what we have seen is basically between the cluster, if the distance is very high, then we can say there are different clusters. But if the distance is very, very low, then we can say it's the same cluster. So what he's trying to do by these particular data points are that the the cities which are basically in the same cluster, he's trying to say that these cities are basically near to each other, whereas the cities which are having greater distance are basically the cities which are basically far off, and that's why you need to have a particular travel by air in this particular case, and it is very efficient. Now, in case of this particular thing, agglomerative clustering, what he has done is he has basically used that particular data, and he's clearly identified those particular cities where the distance is very less. He has identified into the different clusters which are there. As you can see out here, this is all depending on the distance parameter that he has taken, and he has formed the different clusters. And now he can easily say that the distance between one cluster to the other is very, very high, but the distance between one cluster and the second cluster is very high if the clusters are different. But if the clusters are same, then it is very much possible that the distance is very low, and in which case you do not need air travel between the two. You can see out here that he has basically created the hierarchical chart, and you can say that how he has basically done it. He has basically assigned each of the item to its own cluster, and then what he has done is basically he has basically gone ahead and merged most of the similar clusters into a single cluster, and then he has calculated the distance also between the clusters, and he is going to repeat that and then form the cluster. For example, say the cluster 1 and cluster 2, the distance between two clusters is very very high, and there is a minimum distance, there is maximum distance, and there is average distance that he has calculated from the data points. And when he has calculated from the data points, on the basis of that, he is going to say whether it belongs to cluster 1 or to cluster 2, and then he is going to form the particular cluster. And when we are saying that what is the distance that is there within the uh, between the different clusters, he can either take a single link, or he can either take an average, or he can take the centroid or the middle. So it's up to us which particular method we want to take and want to find this particular distance. Now, when he is doing the k-means, he is basically doing partial clustering of the algorithm, and then he is doing this particular data into k clusters is what he is forming. As you can see out here, let us take the picture, and this picture you can see we are having dots which are there, and as you can see out here, when we are having this particular dot, we are saying that K1 and K2 are the particular points wherein we want to form the cluster, and the way we are going to draw a line is what we are trying to have two different type of clusters. One cluster of the points which are nearest to one of the K1, and the second point data point which are nearest to K2 data point. And as you can see out here, when we draw the line, we just draw the line in all directions so that we are able to differentiate and we are able to form different type of clusters is what we do. Then what is the mechanism in basically going to go ahead and particularly the value of k. Now, when we are doing this particular exercise, what we want to say is basically we just want to take the initial centroid, and then we also want to decompute the centroid after each of the uh, angles, and then we want that if there is a convergence criteria, if it is not met, then we will go again, we'll go ahead and do that. The point when we are trying to stop is that the sum of the square which is there is basically the sigma of 1 to k, and the sigma that x belongs to element the distance where it is minimum, that is known as the sum of the squared error. And if this particular thing is minimum, then we can say that we are going to go ahead and get the clusters, optimal number of clusters. And we are also going to have some of the screen plots. We're going to do exercise, that is the elbow point. That's the point of which we are, when we draw the particular graph, we are going to get the elbow point, or which is also known as the screen plot, and that is the minimum number of basically clusters that can be formed. Now, with k-means, we have seen the particular type of algorithm, And then you can see k-means, uh, like the k-means produces a single partition, whereas the hierarchical gives a partitioning of different partitions. And then in the k-means, what you're going to have needs the number of clusters, whereas in the hierarchical one, we do not need the number of clusters. And k-means is usually very, very efficient, but in the case of hierarchical clustering, it may be slow. And then we just want to say that when we are evaluating the clusters which are there, we generally have some which is known as the DB index. Davis Baldwin index is what we are going to calculate, and this you can see the formula out here, and this tells us that the objects which lie in the same cluster are going to have similar number of properties which are there, whereas the objects which are there under a different cluster, for example, cluster 1 and cluster 2, the distance between them is going to be very, very huge. Like we just want to tell you that when we are doing clustering algorithms, we want to ensure that the cluster which we form is basically going to have a particular area, and this similarity area which is there is up to us, and we can decide how many number of cluster bonds depending on the type of algorithm that we are choosing, and it's very, very thing. Now, when we are applying the KMC, it is very, very easy to go ahead and determine the value of K. As you can see out here, this is the script point in the bottom, and this is the script point which tells us the number of algorithms, then the value of K that we should be taking. And the silhouette plot is also one of the plots which is there, which we all form, and the silhouette value you can see which we are getting is basically given out here in the formula, and this particular formula is what is going to give us the silhouette point. What we want to tell you as summary is that we have talked about clustering, and this clustering is basically the unsupervised type of learning which is there, and what we have to do is basically we can either use the k-means clustering or the agglomerative clustering algorithms which are there, and then we form the clusters. The practical issue while using the above algorithms is what we have also studied. We also studied how we'll do the cluster evaluation and we'll stop at which point. So there are different type of clustering, and we have mainly concentrated on the k-means clustering and the mirrors clustering, but the other forms of clustering are also the density based, the spectral based, the constraint based, and these particular algorithms are there and we can use. So in machine learning, like we cannot say that one type of clustering will work the best. It is always possible that one type of algorithm may not work at its best. So we have to apply the different type of algorithms, and we have to say wherein we get the best result, and depending on the best result that we get, we should go ahead and try to choose that particular algorithm for that particular case. These are some of the references which are there, and the books that I have provided you. If you go through those books, you will be able to see some of the Python code and exercise. I request you all to go ahead and do it. And these are all notes is what we'll be sending in the WhatsApp group, that the Google Classroom will be giving all this particular material so that you can go through it before your interviews and you can explain to them. Thank you very much for listening to me. And now we just request the respective teams and their team leaders, that the faculty members, to go ahead and present for the previous assignment that we have talked about. And we'll also give you one of the assignment in the area of clustering, that is unsupervised type of learning, which is there. So over to you, Sudhakar sir and Sarath sir, and I request that the previous assignment which was given is basically on classification, and the respective groups and the respective teachers can go ahead and present it.
Sir, thank you, sir.
Thank you, madam.
We'll do, sir, that today we'll do the teams and we'll continue that.
Um, Durga madam, I
Yes, sir.
just want to ask you
Sir.
that you have been assigned some teams, right?
Yes, sir. Yes, sir.
Uh, those students,
Sir.
uh, are they going to present before everybody of us? And like you faculties, like there must be some more faculties which are there.
Sir.
I was told that there are a total of 5 faculties,
Yes,
and if I can have some of the presentation
sir.
done, like that would be really great.
Okay,
And for the topic today, that is about the unsupervised step of learning,
sir.
the assignment will be given out,
Okay,
and this particular assignment will be given out to the students, and the faculties will have to mentor the
okay,
students also
okay, sir.
for the
Definitely.
second assignment. So I'm just talking regarding the previous assignment of classification, that is the previous day, and I just want you that you and the other faculties, whatever your students have done with respect to classification, please, in next half an hour, you please present it.
Okay, sir. Okay, sir. Definitely we'll continue, sir. That one.
Yeah. Thank you, Durga madam.
Okay, sir. Thank you, sir.
Sir, Rajesh sir,
Yes, sir.
uh, sir, today few of the new students have joined, sir,
Yes, sir.
and also we have assigned the mentors to the students.
Okay.
They will follow up the assignments,
Okay.
and also uh, we will forward your materials to the students and the mentors also, sir.
Okay.
And if at all any doubts they receive, they will post in both Google Classroom and also in WhatsApp, sir.
Yes, sir. Yes, sir. Definitely, yes. I request for the previous assignment, that's the assignment on classification the previous day, whatever the students have done and whatever the faculty has guided them, if it could be presented to everybody, then everybody can learn about the assignment that was given the previous day about classification. This is number one. And number two is today one assignment, new assignment will be given to all the students and to all the faculty members on clustering. And you will have to, the faculty members will have to guide so that the students can do it and present it next Saturday. So I believe the time is 1 week. And I'm just now requesting we have half an hour more and the students can present now.
Okay, sir. We'll make them to present.
Yeah. Thank you, Mr. Commander.
Sir, thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir. Thank you, madam. I request group number 1 to go ahead and do the presentation of the assignment that was given in the previous week. That's on classification.
Sure, sir. We will submit.
Like the submission is okay, madam. Like you can submit it in the Google Cloud, Google Classroom.
Yes, sir.
Like I just wanted to have that this forum be used as the presentation forum wherein the students can present and the faculty members can guide them. And I'm just talking about the previous assignment which was given on the supervised learning, that is on the classification. Like you can tell how you have gone about doing it, madam. Your student can tell and you can guide them.
Okay, sir. We'll take in the classroom, sir. That one. Do.
Okay, madam. So you do not want to do it in front of all the students who are there in the.
No, the students are in the class, sir. We'll present. We'll do on the board, sir. That's why.
Okay, madam. Fine. Now let us talk about this assignment of today that we are going to give.
Sir.
The assignment of today that we are going to give all the students and the faculty members are supposed to guide them is
Okay, sir.
the assignment on the topic that we have discussed today. And that is That is on the topic of clustering. And what we are asking is, we are asking that you do it in Python and you try to form some of the clusters and you determine using the elbow graph or the scree plot, which is best for determining the value of k. That means how many clusters we should have, and given the particular data set, we can easily know from the plot, we can easily know the value of the number of clusters that are required to form. And when we plot, we just get the value of k, and then we have the clusters which are there, and we have different data points in this particular cluster. So the assignment for today is on clustering, wherein we have to determine the number of clusters that are best suited for the data, and also we determine that what are the data points which are there in each of the cluster. So this is the assignment on clustering that we'll be giving for today. Uh, if you have uh, for the last assignment on classification, if you want to present it and submit it separately in the Google Classroom, that's fine. If you want that you present it only to your faculty members, that's also fine. And I spoke regarding the assignment which is there for today. Request you all to go ahead and do the assignment within a week on clustering, and go ahead and post it on data on Google Classroom, and wherever you want to present it, that is fine. But the
Okay.
best thing I just want to say is that if some presentation can be done to everyone, then it is basically going to help both the students and the faculty who has guided them. So it will be really good. Thank you very much.
Okay, sir, we'll do, sir, and we'll post on the classroom, Google Classroom, sir.
Uh,
Everyone.
yes, one.
We'll do today's assignment also, sir.
Yeah. Today's assignment will be sending you in 2 3 hours.
Okay,
We'll
sir.
be sending you the assignment for today
Okay, sir.
in the next 2 to 3 hours.
Okay, sir.
And what we request you is basically you do it with the
Sir.
help of the students can do it with the help of their mentors.
Sir.
And once they do it, they'll basically get some idea about what is this type of unsupervised learning or clustering which happens, and when we have this particular data points, how really do we go about clustering them. And I
Okay.
request you all to use Python as you have used in assignment number 1. And once you do it, you will get a fairly good idea about clustering.
Okay, sir. Okay, sir. We'll do, sir.
Thank you very much, madam. And
Thank
thank you very much to all the students. And since there is no presentation today, it's okay. But from next class, my request is that if you can do some presentation on the work that you have done on the assignment that is given to you, Like next Saturday, you can present before everybody. You can present assignment one and assignment two. That is good enough. And if you can make one slide, at least one or two slides, and then you can show your program that you have written in Python. Whether you write in any of the IDEs like Spider or Google Colab or something, then it is good enough for all of us to go ahead and.
Okay, sir.
Yes.
Okay, we
Sir,
will present
I
on
had a
Saturday.
question. Sir, sorry, I had a doubt, sir.
Yeah, madam.
Sir, each students need to present what the work have done, sir.
No, no. Superset sir is going to go ahead and have the groups.
No,
Uh,
sir. What I mean for the next week. So students have to present what the assignments they have submitted. That's what my question, sir.
no, next week, for example, the student, the we know, for example, if there are 50 students and there are five faculty,
Okay, sir.
so 10 in a group.
Okay, sir.
So these 10 people is what you are mentoring, the faculty
Okay.
member is mentoring,
Okay.
and you can say that you are having 10 people in a group. And when you are saying you are having 10 people in a group, out of
Oh,
that,
okay. Okay.
any one of the student,
Okay.
he can just come and he can present one slide as to
Okay.
what his group has done. And the
That's what I'm asking you, sir. The student has to present for the next week, no? So we have to
yeah, yeah, for the next
uh,
week, one slide and one program.
that's what I'm asking, sir.
The student can basically prepare that and he can present it to all, and the
Okay.
faculty member can guide them
Yes, sir. Yes, sir. Okay.
so that the student, when he's presenting to everybody, that particular student has some uh, good handle
Yes.
over the
Yes.
Python
Okay.
program that he has
Yes, sir.
written,
Mm.
and it
So
will
he
help the
explains for
student
the
to go ahead and present the work of machine learning
okay.
and also his presentation skill. And my request is that the particular student can be rotated by the mentor,
Okay.
faculty member,
Sure,
so
sir.
that the different students and all the students in the team get
Yes.
a fair chance to go ahead and do the presentation.
Okay.
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 Uh,
Thank you.
Thank you very much,
Thank you, sir.
and thank you very much, madam. Thank you very much, everybody. Thank you very much, students.
Thank you,
And,
sir.
Thank you, sir.
the next lecture is going to be on next Saturday at 10 o'clock, and we are going to do a different type of learning in the area of AI and machine learning.
Okay, sir. Thank you, sir.
Thank you very much, everybody. Thank you very much.
Okay. Okay. Thank you so much, sir.
And we will post the assignment on clustering in the next 2 to 3 hours by today, and request you all to go ahead and do it. And the faculty members can basically be mentoring all the students, and let's make it a successful one. Thank you very much and have a nice weekend. Bye bye.
Okay, sir. Thank you, sir. Bye.
Thank you, sir.
Ah.